Hello guys, this is a step-by-step solution to paper 1-3 of the May June 2024 math paper for IGCSE. So let's get started. Okay, so question 1. The diagram shows the graph of this for this, where a, b, and c are constants. Find the value a, b, and c. Okay, so the value of a is the amplitude, and then b shows like how many complete graphs is like within 360 degrees, and then c is like how much the graph moves up or down by, so like how much it shifts. Okay, so in order to like figure out the a, b, and c values, we can first like identify the so-called like middle of the graph, which is this part. And then from this we can find the amplitude, which is from 2 to 6, which is 4, because 6 minus 2. So a equals to 4. And then next we can find the b value. And remember, this is how many complete sine graphs is in 360. So a normal sine graph will look like this. And we can see that a quarter of the complete graph is within 240, because this point is like the maximum and it's within 240, so we can write this ratio. Actually 1/4 equals to 240 degrees, and then we want 360 degrees, so it would be 3/8. Therefore b equals 3/8. Okay, to find c value, it will help that we know the amplitude is 4, so the peak of the graph will be at y equals 4. And if it hasn't been shifted up or down. But because the peak is at 6, we know that it's shifted up by 2, so c equals to 2. Question 2. Solve this equation giving your answers correct to 2 decimal places. Okay, so for this question, we should change it into a quadratic, letting y equals to 2 to the power of x. Okay, so we should change this to, to like separate it. And because y equals 2 to the power of x, it becomes 2y squared. And now we can just sub this back into the main equation. So it becomes 6y squared minus 11y plus 3 equals to 0. And then we can put this into the quadratic equation. Y would be equal to 3/2 or minus 1/3. And then now to find x value, we can do this. And then use logs to find x. Wait, sorry, this is not minus. Okay, since they want it in 2 decimal place, leave it in 2 decimal place. Okay, so that's the final answer. 3a. Find the coordinates of the stationary points on this curve. Okay, so first we can expand this equation. And then like simplify it. after expanding. Okay, so we need the coordinates of the stationary point, and a stationary point lies on the turning point of a curve where the gradient of the tangent is equal to 0. So we can differentiate the equation and equate it to 0 to find the x values for the stationary point. So let's differentiate. We take away 1 from the power. Okay, and this will be the equation, and then equate to 0. Then we put this into the quadratic equation. X equals to 11 over 6, or x equals to minus half. And then, because we want the coordinates, right, we should sub the x values back into the original equation. Okay, so these will be the coordinates. Part B, sketch this graph stating the intercepts. Okay, since we already have the expanded form, it's easier to use the expanded form to deduce how the graph will look like. And from this, we can tell that the coefficient of x cubed is positive, so the graph will definitely have this shape since it's positive. And then from this equation, we can also deduce that the y-intercept will be minus 3. And then for cubic graphs, it can either intersect the x-axis once, twice, or 3 times. But for this graph, it will only be 2 times because we can actually find the roots from the equation by equating it to 0. And it should give minus half and 3. So x equals minus half, x equals 3. And also we found the coordinates of the turning point in part A, so we can roughly tell which quadrant the turning points of the cubic graph will be in. And now we can just draw it out. And so the graph will touch the x-axis at one point, minus half, and then the y-intercept will be minus 3. But let me just adjust it a little bit. Okay, so this will roughly be how the graph looks like. Part C, write down the values of k for which the equation has exactly one solution. Okay, so the equation can only have one solution at this part and here. And for this part above, it will be k equals to 0 because k is the y value. And this part is right below the turning point. And the coordinate for this, the y coordinate for this turning point is minus 686 over 27. So it would be k less than minus 686 over 27. Okay, so we can just write this. Okay, so question 4. Find the integration of this, giving your answer in exact form. So firstly, we can expand the term inside. And this will like make integration easier. And then let's just rewrite it. Okay, now we can like integrate it. Okay, so to integrate this part, we can actually use this rule, which is ax plus b dx equals to this. So we can just apply this rule and then like get this part. The same applies for this and this. Okay, so this should be the exact form. Part 5, when this is plotted against x cubed, a straight line graph that passes through the points is obtained. Find y in terms of x. So we know that e to the power of 2y is plotted against x cubed. We can firstly find the gradient using the points. And then we can use y equals mx plus c to find the constant, since we already have the coordinates that we can use. So c equals to 4. And now we just construct the equation. And then switch y with this and x with x cubed. And since the question wants y in terms of x, we have to make y the subject. Final answer. Part B, find the values of x for which y exists. Okay, so for y to exist, we have to make sure that the value inside ln is not negative, and it has to be larger than 0. So you can write this equation, and then once you rearrange, x cubed will equal to minus 8 and x will equal to minus 2. And then the answer must be x is larger than minus 2, because anything smaller than minus 2 or minus 2 itself will not give a real result. Okay, question 6. Find the differentiation of this. Okay, so we can use quotient rule because the equation is a fraction. So let u equals to the numerator and v equal to the denominator. And then you differentiate. Okay, so apply the quotient rule by solving these values into the equation. And we can just leave the answer like this. So part B, given that x increases from 1 to 1 plus h, where h is small, find the approximate corresponding change in y. So we can use the formula delta y over delta x equals to dy dx. Okay, so we have change in x, which is 1 plus h minus 1, which gives us h. And then we have dy dx from the previous equation, and we can just sub 1 into this to get the dy dx value. Then it should be 0.322. And then to find change in y is dy dx times delta x. So it will be 0.322h. So part C, when x equals 1, the rate of change in y is 3 units per second. Find the corresponding rate of change in x. Okay, so delta y equals to 3. And dy dx is still 0.322 because x equals to 1. And we want to find delta x. So delta x will be delta y divided by dy dx. So 3 divided by 0.322. It'll give us around 9.31. Question 7. A 6-digit number is to be found using these digits. The 6-digit number cannot start with 0. And each digit can be used at most once in any 6-digit number. Find how many of these 6-digit numbers are divisible by 5. Okay, so for the 6-digit number to be divisible by 5, it has to end with either 0 or 5. Okay, the first scenario will be 5, and the second scenario will end with 0. Okay, so we know that it cannot start with 0. And for the first one, because it cannot repeat, the first number also cannot be 5 if the last number is 5. So the total numbers is 10. And then this will be permutation because the orders matter. And we can write 8p1 times 1p1 times 8p4. We should give this answer. And we use 8p1 because there's 8 possibilities for this part. For the first number, basically. There's 8 possibilities since we already ruled out 2. And there's only 1 spot, so 8p1. And 1p1 will be 5. And 8p4 is the remaining 4 slots for the numbers. And then once again, 9p1 times 1p1 times 8p4 equals to 15120. And then you just add both of them. The number of combinations of n plus 1 objects taken 13 at a time is equal to 16 times the number of combinations of n objects taken 12 at a time. Find the value of n. Okay, so for the first part of the question, n is equal to n plus 1. And r will be equal to 13. And for the second part, n equals to n, and r equals to 12. And the question says that 16 times of the second part is equal to first part. So we can form an equation. But first, let's write down this. Okay. And then we can use the combination formula, which is n factorial over r factorial times n minus r factorial. You can use this. After expanding it, we can simplify the some of the like terms. So like this part, and this part, and as well as this part and this part. So it will become okay. So you can also factorize out. You can also cancel out the 12 factorial and 13 factorial, which leaves the this part as 13 only. This part. So it will become like this. And then you just move 13 to the other side. Okay, so this is the final answer. Question 8, the line L is the normal to the curve at the point where x equals to 2. The point minus 2k, where k is a constant, lies on L. Find the exact value of k. Okay, so the normal to a curve means that it is the perpendicular bisector to the tangent of the curve. Firstly, we can find the tangent by differentiating. And let u equals to 5x plus 6. And then y is equals to 3u to the power of half. And then you differentiate the inside. Okay, now you can sub x is equal to 2 into the dy dx to get the gradient of the tangent. Okay, so now you can sub x is equal to 2 into dy dx to get gradient of the tangent. So the gradient of the tangent is 15 over 8, And because we want the perpendicular bisector, since it's the curve, the gradient would be minus 8 over 15. And then we can sub 2 into the equation of the curve to find the y value. So it'll be 212. And then we can get the equation using y equals mx plus c. So let's find the constant. Okay, now we have the equation of the normal L. We can find k by subbing x is equal to 2, minus 2, sorry. To get 212 over 15. So k will be equal to 212 over 15. Question 9. A particle P moves in a straight line such that t seconds after leaving a fixed point 0, its displacement as is given by this equation. Find the velocity v of P at time t. So the question gave us the displacement equation. We just have to differentiate it to get the velocity equation. And then remember to multiply the differentiation of 2t. Part B. On the axis, sketch the velocity time graph for this, stating the intercepts with the axis in the exact form. Okay, so the equation we found in part A can be put to use for this. And normally a sine graph would look like this. And since the equation tells us that the amplitude would be 8 minus 8, and we know that it's plus 4, so the graph has shifted up by 4 because it's positive. So the maximum value would be 12 and the minimum value would be minus 4. And then to find the y-intercept, we can sub t equals to 0 into the velocity equation to get 4. So y-intercept is 4. And then to find x-intercept, we make y equal to 0, and then we just rearrange. And because sine 2t is equal to a negative number, we find the angle in the quadrants where sine is negative, which will be the third and the fourth quadrant. And then t will be 7 pi over 12 and 11 pi over 12. So the sine graph will look like this. And the y-intercept is 4. And this is 7 pi over 12. And this is 11 pi over 12. C. Find the acceleration of P at time t. And we can write the equation of the velocity first to make it easier. And then when we differentiate this equation, we will get acceleration. Multiply the inside, and then 16 cos 2t. Okay, question 90. Find the times when the acceleration of p is 0 for this. Give your answer in terms of pi. So the acceleration equation is a equals to 16 cos 2t. And then we make this equation equal to 0 since acceleration is 0. And then cos 2t equals to 0. Inverse of cos 2t gives us the base angle pi over 2. And then cos is positive in the first and the fourth quadrant. So to find the angle in the fourth quadrant, you take 2 pi minus the base angle, which gives 3 pi over 2. And then you divide both of these answers by 2 to get the t values. And these values fit this range given in the question, so they are the final answers. Question 10. In an arithmetic progression, the first term is a and the common difference is d. The sum of the first 3 terms of this arithmetic progression is 42. The product of the first 3 terms of this arithmetic progression is minus 6720. Okay, so the sum of the first 3 terms. So this means that n is equal to 3. And we can use the sum formula for arithmetic progression, which would be n over 2 2a plus n minus 1 times d. And then we just sub n equals to 3 into the equation. And this is equal to 42. Okay, so we have the first equation. And then the question says that the product of the first 3 terms of this arithmetic progression is minus 6720. So we can find the nth term for arithmetic progression, which would be a plus n minus 1 over d. Okay, so when n is 1, the value is a. When n is 2, it's a plus d. And when n is 3, it's a plus 2d. And so the product means they're all multiplied together to equal to minus 6720. Okay, now we can use this equation and sub it in to get this. And this is the format that the question wants. So we have proven the question. Okay, so part 2. Hence, given that a is positive, find the values of a and d. So we can make this. We can use this to make a equal to 14 minus d. And then we sub this into the equation in part 1 so that d is the only unknown. So 14 minus d plus 2d equals to minus 480. So we're using this equation. So D will be plus minus 26. And then we need to find the A value. So we just sub it back into the equation. So this will give us minus 12 and this will give us 40. And the question says that A has to be positive. So this is not positive. So D cannot be equal to minus 12. Because A has to be larger than 0. Yes, so D cannot be equal to minus. Okay, so this part is not correct because A has to be positive, so it cannot be minus 12. And this is the correct answer because it's positive. Because it's positive, so A goes to 40 is positive, and then the corresponding D value would be minus 26. So this is the answer. Part B, in a geometric progression, the third term is this and the 10th term is this. Find the first term and the common ratio. Okay, so the third term is when n is equal to 3, and the 10th term is when n is equal to 10. And then we can use the m term formula to get the two equations. It's ar to the power of n minus 1. Okay, so when n equals to 3, ar squared is equal to e 4x over 4. So a is equal to 4r squared. And then the same thing for the second one. When n is equal to 10, ar to the power of 9, and it is equal to the equation. Okay, so now we have two equations that are both equal to A. So we can equate them. Okay, so we can divide both sides of the equation where there's e to the power of something by e to the power of 4. So this part will be 1x and this will be e to the power of 7 times x. And then we can also divide by 4r squared. So it will leave us with 128 r to the power of 7. And then we can rewrite this. And anything to the power of 1 would be 1. Wait, sorry. Anything that has like base 1 to the power of something is 1. So when you divide, it's just 1. And then you can leave it like this. Then r7 equals to this. And r is equal to ex2. Okay, now we have to find the first term, which is a. We can just sub it back into this equation. So the first term is e to the power of 2x, and the ratio is e to the power of x over 2. These are the answers. Question 11. Solve the following simultaneous equation, giving your answers in exact form. Okay, so we have two simultaneous equations that have logs, and the logs have different bases. This one has 3, this one's 81, and this one has 9. But both equations have logs with base 3. So we should change the other logs, which is 81 and 9, to base 3 as well. Okay, so let's change the base first. Okay, so we can use laws of logarithms to make the coefficient the power. And then once again, we use the laws of logarithms to make both sides of the equation only have one term. Okay, so I'm rewriting this equation and then rearranging it. Okay, so both equations have y cubed, so we can equate them. So x is equal to root 3, and then to find y, we can sub it back in. So y is equal to 3 to the power of 1 over 3, and x is equal to root 3. Okay, question 12. Solve the equation for this range, giving your answers in exact form. So we can use trigonometric identities to change secant into 1 over cos. And then we can move 1 to the other side. Then do inverse of cos to get the base angle, which will be pi over 3. And then you can rearrange this to get theta, which should be 5 pi over 18 after you after pi over 3 plus pi over 2 divided by 3. This will give 5 pi over 18. Okay, so find the other base angles. We have 4 quadrants, and cos is positive in the first and the fourth quadrant. So to get the next base angle, we have to take 2 pi minus pi over 3 to get 5 pi over 3. And then once you rearrange this again to find theta, it will be 13 pi over 18. And this is out of the range that is given, so we don't include this in the final answer at least. And then we can move on to the negative quadrant, which means that we go the clockwise direction. So the base angle is pi over 3, and in the negative quadrant it will be minus pi over 3. And we can rearrange this to get theta again, which would be pi over 18. So for base angle minus pi over 3, it will be pi over 18. Then the next angle is in the first quadrant, and remember it's still in the negative side. So 2 pi minus pi over 3 would be 5 pi over 3 again. And this is negative, it's minus 5 pi over 3 plus pi over 2 over 3. So you get minus 7 pi over 18. So minus 5 pi over 3 is the base angle, and minus 7 pi over 18 is the answer of theta. Okay, so this value, and this value are within the range that's given in this question. So these 3 are the final answers. Theta is equal to 5 pi over 18, pi over 18, and minus 7 pi over 18. Okay, so that's it for this paper. Thank you for watching. If there's any questions, feel free to comment in the comment section below. Thank you.